did. Who knows why? We decided to skip it last Friday. We can't skip it now.
Okay,
How
right.
many are there? How many zeros?
4.
Well, why is it 4? Because I only see 1, 2, 3. Because this one has a multiplicity. That's why there's a hump. So, yes, Virginia is correct. Yes, you're right. That hump at the 2 indicated there was multiplicity there. So, technically, it's 2 roots. So, our 4 roots, if we listed them, are -3, -1, 2, and 2. Hence why Virginia decided to be smart and use the phrase double roots. Okay, you got the new math workshop on the way in. Let's do the top 3. They're factoring. My gosh, I pray you can factor. Oh, I love the first one. It's difference perfect squares. Yay. I would love to give out some points this morning. Is that what you said, Hunter? Did you say this? Okay, you can have your point. I know someone else said it too, and you can have your point too. I just heard Hunter clearly. Okay, number 2, I need 2 things that multiply to -60 and add to -4. Thank you, Eduardo. -10 times +6 is -60. -10 plus 6 is -4. That's perfect. Oh, no, number 3 has that leading coefficient number 2, so we're going to have to guess and check. X minus 1, you think? Okay, let's see if Eduardo's right. If he is, his group can not only have, he should have got a point for number 2 if I didn't say that already. He might get 2 points for number 3 for getting that so fast. 2x squared minus 2x plus 3x minus 3. Does Eduardo get 2 points right now?
No. Wait, flip the signs, make
Yeah.
3 negative and the 1 positive.
So, right this moment, so Eduardo's only going to get 1 point, because at this moment, -2 plus 3 gives us a +1. We need a -1. So, and this is why table 2 is going to get the other point, because his suggestion is, why not flip the signs? So, let's see if he is correct. 2x squared plus 2x minus 3x minus 3. Yes, he is correct because 2x and minus 3 make a -1. That's perfect. Again, guess and check literally means you might have to guess, and then we will check. Okay, we will do some more of these on Thursday. Again, tomorrow is a weird day. Okay, let's go to our notes. And let's talk about some things. So the good news is you don't have a test for a while, but that's also a bad thing too, because the longer it takes between tests, that means the more material is on that test, and the likelier chance you have of making a big goof, which is not necessarily a good thing. So our next test, if you have a planner and you're trying to plan stuff out in life, our next test is not till 2/28, so it's 8 days away. That sounds so lovely. Like, yay, I don't have a math test for 8 more days. But sometimes that is not a good thing. In fact, I think it's a very bad thing in our case. Last week, we talked about adding functions, subtracting functions, multiplying and dividing. Everyone seemed good with that. This is the one that everyone was struggling with, composition. We all struggle best through that checkpoint. In fact, a lot of us had to get some help on that checkpoint. So if there was something I was going to study over, it would be composition. And then last Friday, we were doing inverse. And you had a worksheet you were supposed to do. And that's one of the things I want to see today. But to remind you with inverses, what do you swap to find an inverse? Yes, 6, you get a point. You swap the x and y's, and then you solve for y. That's literally all we're doing. Swap x and y and solve for y. So, for instance, on this worksheet that I haven't seen everyone's of, I changed the f of x to a y. I swap the x and y, and then I solve for y, and I have the answer. change the f of x to a y, swap the x and y, and then solve for y. So inverse was actually really nice, and we rocked that. And then today the word inverse is still up there, so life seems pretty good. Did you need that still? So today the word inverse is up there, so life seems pretty good, but I warned you on Friday, yeah. That extra day off just threw me off. I warned you on Friday that today, yes, inverses is still the key word, but we're going to have to use function composition as well. So the thing you struggled with is coming back today. Okay, let me show you what I mean. So in our notes, not at the bottom of page 8, go on to the back, the very back page of your notes, the bottom 3 is where we're going to be today. The bottom 3. Now, we kind of talked about this last week, that inverses tend to be the opposite operations. So I'm going to guess that this number 4, they're not inverses, because they're not completely opposite operations. I see a plus 3 and I see a minus 3. But since I see a times 2, shouldn't something in the second one be divided by 2 instead if they were truly opposite? So I'm guessing it's a no on 4. Again, we're going to prove it with math. This is just me using my logic. I'm guessing it's a no on 4. But 5 looks pretty good because opposite of adding is subtracting. Opposite of multiplying is dividing. So 5 truly looks like opposites. So maybe the 2 functions on 5 really are inverses. Okay, well here's the part that stinks. To check whether or not 2 functions are inverses, you have to actually do Fogg and Goff. So sad day, we have to use Fogg and Goff again. So if they ask you to determine if a pair of functions are inverses, you've got to check Fogg and you've got to check Goff. Now, Seth does not necessarily have to check both. If one of them fails, then just stop. So right now, if we check Fogg and we fail, we're just going to stop. So you only have to check both if you truly think they're inverses. Okay, so f of g of x, let's see, g of x is 2x minus 3. So I'm actually wanting f of 2x minus 3. Because g of x is 2x minus 3. Well, f was 2x plus 3. But you and I both know when we put this thing in parentheses, everywhere we used to see an x, we're putting that thing in parentheses. So again, f was 2x plus 3. This is our value for x. So we're going to plug in 2x minus 3. What we're hoping is that everybody's going to cancel out and we're going to end up with just an x. But I don't think it's going to work out this time, because if we distribute that 2, we'll have 4x minus 6 plus 3, which is 4x minus 3, which is not what I'm wanting. Because if they're really inverses, you'll end up getting, with Fogg and with Goff, you'll end up getting just a plain old x. And we did not get just a plain old x. So number 4 is done already. So yes or no? No, not inverses. So again, we got to remember how to do Fogg and Goff. But if we use Fogg and Goff, we can prove, yes, these 2 are inverses, or no, they're not. And these 2 failed because we wanted an x. The answer needed to be just x, and instead our answer is 4x minus 3. Sad day. So that was number 4. Let's try number 5. So I'm going to try Fogg on it. Again, I don't even bother with Goff. If Fogg fails, why even try Goff? So I'm wanting f of g of x. Well, g of x in this case is x minus 6 over 4. Well, f is 4x plus 6. So it used to be 4x plus 6. But now everywhere I used to see an x, I'm plugging in this. So it's going to be 4x minus 6 over 4. And I'm feeling pretty good about this. I'm feeling really good about this. Why am I feeling really good about this? Yeah, 4's cancel out, and then what happens? The 6's cancel out, and what is our answer? So we're feeling pretty good. I'm thinking it's going to be a yes. Now, again, I'm a good student, so I'm going to check golf as well. But if you're super excited and you quit there, I totally understand. But the math person in me knows I have to check both ways. So fog worked out. We're happy. We're thinking it's a yes. We're going to check with golf just in case to make sure. So golf, I know f of x. F of x is 4x plus 6. So g of 4x plus 6. Well, g is x minus 6 over 4. But my x isn't just an x anymore. It's everything inside these parentheses. So I've got to put 4x plus 6. But it's looking good again. Why is that? Who cancels out? Can the 4's immediately cancel out? The 6's immediately go plus 6 minus 6. So we have 4x over 4. And then Dave's right. 4's die and we end up with just x. So we checked both fog and golf and it worked out both ways. So yes, inverses. Yes, dear. Yes. So that's what, remember the other day when I say fog and golf rarely have the same answer? Because rarely are two functions inverses. Fog and golf will only have matching answers, like 2x's, if they're inverses. I'm telling you, every single time, if they really are inverses, your answer is going to be straight up just an x. So the second we got 4x minus 3 and not just an x, I knew it was a fail. Yeah, even golf. Even if golf gave me an x, the fact that fog did, like, they both have to give you x. So if one fails, why bother with the other? But yeah, see how rarely this happens? Like, number 6 is probably going to be a fail. I don't know. Number 6 kind of looks good because the negative 1/3 and the negative 3. But you and I both thought plus 3 should have been a minus 3. I don't know, but fractions are weird, as we found out the other day. So there's potential for 6. But basically, most functions aren't inverses. So most functions don't have the same fog and golf. Okay, so let's do 6. So f of g of x. I want to check the fog. If I look at number 6, my g of x is negative 3x plus 9. My f is negative 1/3 x plus 3. But everywhere, and I used to see an x, instead I'm going to put negative 3x plus 9. And I'm feeling pretty good about this one now. Why am I feeling pretty good about this one? Yes, the 3's cancel out when I distribute that negative 1/3 times negative 3 at negative times negative gives you a positive. They do cancel out and I have just an x. That's true. But I still got this 9 and this 3. What else happens? Say it again. We do need to, what did I not finish doing? I got to do, yes, 6, you can have a point. So negative 1/3 times 9 is negative 3. And then we had a plus 3. So yay. We really do end up with just an x. So we're feeling pretty good about this one. Fog worked on out. If I was a betting woman, I would probably say golf's going to work on out too. But it doesn't kill anybody to check, especially since we're struggling with fog and golf. A little extra fog and golf practice hasn't hurt nobody yet. So f of x was negative 1/3 x plus 3. G is negative 3x plus 9. So it used to be negative 3x plus 9. But instead, I need to plug in this. So negative 3, negative 1/3, x plus 3. And I wrote that super tiny. That is some ugly stuff. That is ugly, ugly. That is a 1/3. A negative 1/3 x plus 3. When I distribute negative 3 and negative 1/3, that ends up being a positive x. Negative 3 times positive 3, that's a negative 9. Plus 9, oh my goodness, it worked on out again. So yes, they're inverses. So moral of the story is you hated Fogg and Goff, but it turns out it's really useful when we're trying to check whether or not two functions are inverses. We can use Fogg and Goff. If we get the answers x and they match, then they are inverses. If we fail, even with just Fogg, there's no need to keep continuing because it's just an epic fail. And I thought there was practice on this page, but there's not. So did I see your checkpoint from last week? Have you shown me this worksheet from Friday? It's a grade. It says page 10 down at the bottom of it. And then if you've done all those things, and clearly you want to practice Fogg and Goff and inverse functions and stuff, come see me. I'll go ahead and give you the study guide. Yes, I know the test is not until 2:28, but Lord knows it wouldn't kill you to get a head start